These are notes 3.2. We're going to talk about quadratics and graphing them. Okay, so we're going to have two different forms. Standard form would be y is equal to some number x squared plus some number x plus some number. And vertex form, we're used to that being, we've graphed that already this year. So x minus h squared plus k. I'm noticing this is where it gets shifted up and down, and this gets shifted right and left. Okay. Okay, so what we're going to do is first thing we want to do is we want to take this and we want to put it into vertex form. Okay, we're going to use something called completing the square. And if you remember factoring, okay, if I had this was a perfect square trinomial which would factor to be x plus 3 times x plus 3, which is the same as x plus 3 squared. Okay, so what we want to do is we want to get it to look like this so that we can factor it down to be that. Okay. So what we're going to do first is, first step, we want to get this to be a 1x squared, which it already is. Next step is to take this 11 over to the other side. So we'll have p of x minus 11 equals x squared plus 6x. Okay, now here's where the completing the square idea comes in. Okay, so we have to think, what are we going to do to get this to be a complete square? And what we do is we take half of this number and square it. So half of 6 is 3. 3 squared is 9. And what I do to one side of the equation, I got to remember to do to the other side as well. So then I would have p of x, and if I put these together, minus 2. If I would factor this, that'd be x plus 3 times x plus 3, which is x plus 3 squared. And the last step is to get p of x by itself. So if p of x is equal to x plus 3 squared, and then plus 2 to the other side. Now we have it in vertex form, and it's easily graphed. We know it goes up 2 and to the left 3. And we can draw a sketch of it. Okay, so next one. First step, this is already a 1x squared, so we're good. Second step, add the 18 to the other side. Okay, now to complete the square, if you remember what we did here, what do? Take half of this and square it. Okay, half of it is 5. 5 squared is 25. So add 25 to both sides of the equation. Sometimes I forget to do it to both sides. Okay, so we would have p of x plus 43 on this side. And this here would factor down to be x plus 5 squared. It's always half of that number, okay? But you can think about your factoring we've just been doing. And then get p of x by itself. X plus 5 squared minus 43. Okay, if we're going to draw a quick little graph, we know it goes down to negative 43, and it goes this way 5. So there's our vertex. Okay, now this one's just a tad bit different because it has a 2 here. The only thing we have to do is just to divide everything by 2 first. So then I have x squared plus 2x minus 8. Okay, now I'm back to the first, like we did over here, just an x squared. So I'm going to take that x, the 8 over. Okay, then I got to complete the square. So what's going to complete the square? Half of this is 1. 1 squared is 1. Add 1 to both sides. So I have p of x divided by 2 plus 9 equals x plus 1 squared, factoring that down. I'm going to add the 9 over. Subtract the 9 over. And lastly, to get p of x by itself, I'm going to multiply by 2. So I'm just going to put the 2 out front there. Okay, but here I got to remember to multiply this one by 2, so minus 18. Okay, now a way you can check yourself to make sure you have it right is in Desmos. If you put this in and you put this in, they should be exactly the same thing, exactly the same graph, okay, just in a different form. Okay, here I don't have that there, the 1 x squared, I have a negative 1, so I got to divide everything by negative 1. So I have p of x divided by negative 1. Okay, I'm going to bring that 8 over. And I got to complete the square. So, think again. Half of it is 3. 3 squared is 9. So p of x over negative 1 plus 1 is equal to, factoring it as x plus 3 squared. Subtract the 1 over. And get rid of this negative 1 here. Multiply it all by negative 1. So I'm just going to put the negative out front here for this first term. And then multiply by negative 1 there. Okay. Try and pause this one. Okay. And do it yourself. And then come back and see if you got it right. Okay. So the first thing I'm going to do is take that 10 over. So plus 10. Okay, now this one's a little bit different because you'll notice half of 3 is 1.5, so we're going to deal with some fractions here, or decimals. I prefer, well, either way is okay, fraction or decimals. Half of 3 is 1.5. 1.5 squared is 2.25. Okay, so this factor down would be x plus 1.5 squared. And over here, p of x divided by negative 1 plus 12.25. I'm going to take that over. And divide by the negative 1, or multiply by negative 1. Okay. Number 6 down here. Okay, so we want to get rid of this negative 4 first. So we get x squared minus x. Okay, so now we got to complete the square here. I should have left a little space here to put that in there. But half of negative 1 is negative 0.5. Negative 0.5 squared is 1/4, or 0.25. Okay, if we factor this, half of negative 1 is negative 0.5, or negative 1/2. Once again, decimal fraction, either way is fine. I'm going to take that over. And lastly, I'm going to multiply it all by negative 4. Okay, one thing I've been forgetting to do is graph. So you know that goes up 1, goes to the right 0.5, and negative 4 means it's opening down. It's going to be pretty skinny because it's 4 times the stretching, 4 times the height. This one here goes up 1, it goes left 3, and it's negative, so it's opening down. Okay, you remember that from before. Okay, number 7. Okay, try and pause it and do it yourself. Okay, so get rid of that 8 again. Okay, we got to complete the square. So half of negative 2.25 is negative 1.25. Squared is 25/16. I don't know why I put it in fraction this time, but I did. So plus 25/16. Okay, I guess because it's a longer decimal, that's why I did it. Anyway, so here, p of x over 2, if I add those together, it's negative 103/16. And this would be x minus 1.25 squared. Take that over. Okay, and the last thing is multiply it all by 2. Okay. So there we have it in vertex form. Okay, now this one's going to lead us into the next set of notes. Okay. Right, so we just got A, B, and C, so we're just going to deal with it. This is just kind of a general formula that we're using. So the first thing we do is got to get rid of that A, right? So we divide everything by a. Okay, next step is to take this, bring it over to the other side. So minus c over a. Okay, next step, okay, once again, we got to complete the square, so we got to see what we're going to add to both sides. So if we take b over a and divide by 2, it would be this. And if I squared it, it'd be b squared over 4a squared. B squared over 4a squared. Okay, so we're adding that to both sides. Okay, so over here, this would be p of x divided by a. If I put these two together, now I could get common denominators. So, I don't know if you remember how to add fractions back from middle school, but c over a, if I'm adding that to b squared over 4a squared, if I multiply by 4a over here, now they're both 4a squareds, right? Okay, so I would have, and if I rearrange this a little bit, and actually this is a minus here, right? Okay, if I arrange this a little bit, it'd be b squared minus 4ac over 4a squared. Remember this from a formula somewhere? B squared minus 4ac, the quadratic formula. Okay. And on this side, I'd have x. Half of this would be b over 2a, quantity squared. Okay, next step is to bring this thing over. And then the other thing is to multiply by a yet. And if I want to get it into this form up here, if I'm going to add k to it, okay, I want this to be a positive. So I'm just going to distribute through a negative a, okay? So this, I'm just going to make that would become a positive 4ac minus the b squared and divided by 4a because I multiplied by an a, right? So an a would cancel out there, okay? So there's our basic formula. Now if we think about this, this is our formula to find the vertex, right? This is where it goes up and down, and this right here is where it moves right and left. And remember, it's kind of opposite, right? If it's minus h, it's actually at positive h. So what we can do here, what we know here is the vertex. So it's the opposite of this, or negative b over 2a gives you the x of the vertex. And then that gives you the y of the vertex. Okay, now what we're going to do is we want to just pretty much look at this part of it. Okay, so another way to graph it, we're going to look at standard form and graph it. So we're going to find the vertex. Okay, so we had just proved here that the vertex is at negative b over 2a. So we're going to use that our vertex, so the x of our vertex is at negative b over 2a. So if I plug it in here, my b is a 4, and my a is a 2. This would be negative 4 over 4, which is negative 1. Now, negative 1 is the x of my vertex. Okay. Now, two different ways you could find the y of your vertex. You could plug a bunch of stuff in, right? A, B, C's, and all the stuff into that. Or, if we know what the x value is, we could just plug it in here to find the y value. So 2 times negative 1 squared plus 4 times negative 1 plus 6. I think that's easier to do than the other one. Okay, so when I plug that in there, I get an answer of 4. Okay, now this is the vertex. So it's going to happen at negative 1, 4. There's my vertex. Now, I know that this graph, since it's positive, is going to open up. So what I want to do is I want to find some points on either side to make sure I get that u. So I'm going to actually put this in the middle. So I want to find 2 points below -1 and 2 points above -1. So let's go -2 and -3 and 0 and 1. Those are points, to the right and the left of it there, okay? And when you plug -2 in there, you get 6. Plug -3 in here, you get 12. Plug a 0 in there, you get 6. Plug a 1 in there, you get 12, okay? So you can see that at 0, 6, and 1, 12, and -2, 6, and 12, okay? So you can get a real nice graph of know where the points are, okay? The extreme points, we're just talking about the lowest point here, which is the minimum. So this one has a minimum at the point -1, 4. Okay. Okay, number 10. Okay, so we want to graph this using this method again. So we're going to try and do it by yourself and then unpause it. The vertex, the x is at -b/2a, which is negative, and your b is a -8/2 times a, which would be 8/4, which is at 2. So I know in my table, the middle of my graph is at 2. Okay? I don't know what the y is yet, so how to find the y? I can take it and I can plug it in right there, right? So 2 squared is 4. 4 times 2 is 8. 8 minus 16 would be -8, plus 9 would be 1. So I know at 2, 1, that's my vertex. Okay? So I want to find points on either side here. So let's go 1, 0, and 3 and 4. Once again, you can take all these numbers and plug them in there. I'll just tell you it's 9, 3 for those numbers. You notice if it's the same distance away from our vertex, right, 1 away and 1 away, these numbers are going to be symmetrical as well. So we're at 1, 3, and 3, 3, and 4. Okay, so you get a nice graph there. So we have a minimum point, once again, at the point 2, 1. If I had the graph open like this, then this would be a maximum point. Okay. Okay. The last part here, we're going to use some modeling. So Head Start provides a range of services for low-income families. The table lists enrollment in thousands, where X is the year after 1970. So this is the enrollment. So in 1970, which is 0, they had 447 enrolled. 10 years later, they had 376 enrolled. 20 years later, which would be 1990, 541 enrolled. And 36 years later, 909 enrolled. Okay, so we're going to find the curve of best fit. So if you remember back, we did in Desmos, we did y1 tilde m x1 plus b, right, to get our slope and our y-intercept. Okay, but here, it's not going to be a line of best fit, it's going to be a curve of best fit. So in Desmos, what you need to do is type in y1 tilde, and we're going to use the standard form. A x1 squared plus b x1 plus c. Now when you type that into Desmos after your table's in, it'll give you your a, b, and c. So the equation is roughly going to be 0.5946 x squared. If you go to a different decimal, that's fine too. Minus 8.025x plus 433.6784. Okay, so that's a 0 there. So I went 4 decimals. You can go 2 decimals or whatever. I don't really care. Okay, the more you do, the more accurate it will be. When was enrollment the lowest? So if we want to make a prediction, according to the model, we want to know where it's the lowest. So our lowest point, okay, think about this graph. It's a graph that opens up. Our lowest point would have to be at the vertex. Okay, so our predicted lowest is the vertex. Okay, So to find the vertex, we're going to use negative b over 2a, right? So it'd be negative and negative 8.025 over 2 times 0.5946. And that comes up to be 6.748. Okay, now what does that mean in this problem? Okay, we know 0 corresponds to 1970, right? So 6 years later would be 1976. Okay, almost 1977, but not quite there yet. Okay, so that isn't, okay, so notice, okay, so if I also want to find the y for this point, I could take this and plug it into my equation. It comes up to be about 406. Now, was that actually our enrollment? Nope, not quite. This is our predicted enrollment on the line of best fit, right? But this actual one was a little bit lower than what our line was. So if you think about a line of best fit, you know, some points are below the line and some points are above the line. Okay? Yeah, but that's our predicted enrollment. So for 2010, if I want to know my predicted enrollment for 2010, okay, from 1970 to 2010, that's 40 years. So I'm going to plug in 40. Okay, so I'm going to plug in 40 here for those two x's, and I get that as an answer. Okay, so that would be our predicted enrollment for 2010. Okay, this is also a nice little equation. This is a neat little, yeah. I've actually had kids use this. One kid I know wanted to know how deep his well was. So he took a rock and dropped it in there and, you know, figured some stuff out. But anyway. Okay, a ball is thrown upward with an initial height of 100 feet. Okay, so let's say somebody's on a building here, 100 feet in the air, and they're throwing the ball. An initial velocity of 80 feet per second. So it's going up, he's throwing it at 80 feet per second, and then coming down and hitting the ground. Okay? This is the equation. Everything falls to the ground at the same rate. So always negative 16. Okay? We're always going to use that there. V sub O is our velocity, our initial velocity. O means initial. And S sub O is our height. I'm not sure why they use that, but height of O means our initial height. So write a function. We're going to have S of t is equal to negative 16t squared. By the way, t is time, plus 80t, because that's our velocity, and we're starting at 100 feet. Okay, so if I think about this function, if I would sketch it, it's starting at 100, and it's going up and then coming back down. That's kind of what it looks like. This is our time, okay, how many seconds is going by, and this is the distance it's going up in the air. Okay, so what does the point 4.8 and 115.36 mean? Okay, it means after 4.8 seconds, the ball is 115.36, I think it says feet, right? Yeah, feet in the air. Okay. When does the ball reach the max height? Sorry, this is kind of hard to see, but we want to know the max height. So our max height would be this point right here, which is the vertex. So to find the vertex, we use negative b over 2a. Okay. So once again, use this equation, negative b over 2 times our a gives us 2.5 seconds. So here at 2.5 seconds, it reaches its maximum height. Okay, so that's when at 2.5. Okay. Actually, let's answer this too. How high does the ball get? Okay, so right here, at 2.5 seconds, I want to know the height of it. So I can take that 2.5 and plug it in there. Okay, and I don't have this number here, but negative 16 plug in 2.5 squared plus 80 times 2.5 plus 100. Okay, it goes 200 feet in the air. Okay, so this is right there. At 2.5 seconds, it's 200 feet in the air. Okay, how long is the ball above 160 feet? Okay, so we want to know where it's at 160 feet. In class, I would show you how to use Desmos for this. But 160 would happen right here at a time of 0.92. And then it stops being that high right here at 4.808. Okay, so from this time to this time, it's above 160 feet. Okay, so that's a total of about 3.16 seconds. How long is the ball in the air total? How long is the ball in the air? So it's in the air the whole time until it hits right there at 0. Okay. So once again, I would use Desmos for this. At this point, we're going to solve this eventually, but using Desmos, we can see where that hits if you put this equation in there, and it is at 6.036 seconds. Okay, that's a height of 0, and it would be out here at 6.303. Okay, those are the notes for 3.2.